Hello, everybody. Welcome to SoCal Loopers. And today is going to be an interesting and slightly different chat for us. It's DreaMed Diabetes AI, which is artificial intelligence, with Eran Atlas, who's the co-founder and CEO. And one of the quotes I picked up from one of the articles was that data equals power, and algorithms can lead to better therapy decisions. I'm sure you all agree with that. So here we go. We'll go with our usual disclaimer. Loop is a do-it-yourself closed-loop algorithm. While it may seem obvious, please consult with your healthcare professional regarding your diabetes management. It's important to remember and understand that this project is highly experimental and is not FDA approved for therapy. Therefore, you take full responsibility for building and running the system, and you do so at your own risk. I'm going to unshare, and I would like to make an introduction because to me, this is one of the biggest issues we're going to be facing is what do we do with all our data? And for those of you who went through the several months of migration from Mongo Lab to Atlas and all the stress and losing your data or not losing your data, that's becoming the buzzword it'll probably be the buzzword of 2021. So let me tell you a little bit about DreaMed Diabetes, and Eran can correct me if I'm wrong. It's a medical device company that provides personalized diabetes treatment optimization solutions. So pay attention to those words. Those are important. The company was established in 2014 and commercialized its first product, MD Logic Artificial Pancreas Technology, which was licensed to Medtronic Diabetes. I believe that might be the fuzzy logic portion that Rehan Lal talked about. Ever since, DreaMed has been vigorously working on the DreaMed Advisor portfolio and decision support tools in the diabetes management space. DreaMed became the first and only company in the world to receive a CE Mark and FDA clearance for its DreaMed Advisor Pro, which is a decision support system for type 1 diabetes patients. The company is continuing to develop the DreaMed Advisor portfolio, which you can kind of look at online, and is continuing, which aids all diabetics and their healthcare professionals. Eran Atlas is the CEO of DreaMed Diabetes, and it's late night where he is, and he's agreed to come on. He's got several people from DreaMed with him. He co-founded DreaMed Diabetes AI to improve diabetes care. He earned his Master's of Science in Biomedical Engineering and MBA at Tel Aviv University. While at the Institute of Endo and Diabetes at Schnieder Hospital in Israel, Eran was part of the algorithm development team, where he had a firsthand experience of designing and executing clinical studies. Eran believes that data equals power. That's what we were talking about. In the field of diabetes, and especially when there is need to make insulin dosing decisions, it is crucial to make the right decision at the right time. I couldn't have said that better. Eran, thank you so much for staying up late, for accommodating our time, and thank you for being here.
Thank you very much, Joanne. I just want to also introduce together with me here in the call for my team, you have Eldad Postan-Koren, our Chief Operational Officer, and Amit Safir, our Customer Success Manager. And we're delighted to have this opportunity to share with you a little bit about what's going on in Israel, across the Atlantic. So let's get started. Just give me a high five if you see my screen, so I know that we can start. Great. Okay. So I will repeat some of the things that Joanne mentioned, give it my own music into that. So DreaMed is a digital therapeutic platforms that provide decision support algorithms and technology, all FDA cleared. And I don't know if you know about that, but we actually created a new product code within the FDA. And at the moment, we are the only company that holds such a FDA clearance. So we shared a little bit with you. And our intention is to provide these solutions to help the needs of people with diabetes, their providers, and also the payers, and extremely looking on the connection between the needs of people with diabetes and their providers, making sure that we have a good relationship there and a good way to manage diabetes. So a little bit about our history. I started working with diabetes since 2007, so I'm here for almost 14 years ago. And we started as a technology group within one of the biggest institutes that treat people with type 1 diabetes in Israel, at Schnieder Children's Medical Center. This institute is being directed by Professor Moshe Philip. I don't know if you heard about him, but he's one of the leading physicians in Israel and globally that push forward for technology to be implemented within routine care of people with diabetes. Together with two good friends of his, Professor Batalin and Professor Dana from Germany and Slovenia, we established what we called that time the DREAM Consortium. And I will not tell you what DREAM meant from an acronym point of view, but the idea was, let's try to develop our own automated insulin delivery algorithm and validate it. It will be our Europe way of thinking. And at that time, there was Medtronic effort, there was Boris Kovachev effort. I'm sure you heard all of these names. Romanov Vorka. There were a little bit about loopers. I don't think there was loopers at that time, but all of them did a lot of, taking engineering way of thinking and trying to implement it into the way that medical field thinks. And what we try to say is like, okay, we have a lot of physicians, part of our team that knows how to read CGM data, insulin pump data, and make decisions about what is the best amount of insulin that needs to be delivered right now. Let's try to automate that way of thinking, and that's the way where we use the fuzzy logic technology. A little bit of pat on the shoulder for us is that we were the first in the world that published about automated insulin delivery study in the New England Journal of Medicine. We were the first in the world, actually, before Medtronic and everybody else, that got regulatory approval for automated insulin delivery. We were the first in the world that sent people home with automated insulin delivery, the beginning just for the overnight, then for 6 weeks. And that was where Medtronic, knocked on our door and told us, listen, you have a good stuff. Let's bring it to our technology and try to embed it together. So at that time, the hospital told us, come on, you're already a company. Go out of the hospital. We established our own startup company, licensed our automated insulin delivery technology to Medtronic Diabetes. And if you're hearing about 780G, so our technology is embedded within the 780G. All the automatic correction balls is basically our technology. And I think that for me, it was a closure, to take a piece of code that I wrote in a computer together with my partners at that time, and now see it inside an insulin pump with the brand name of Medtronic in the hands of people all around the world, I hope shortly. So that is amazing closure for me. At that time in 2015, we decided that there is a lot to do with algorithms and data for people with diabetes, not just in the automated insulin delivery space. So we decided to move on to what we call today the DreaMed Advisor. We share a little bit more about that with you guys. And we heard that Hemsley Charitable Trust launched a request for proposals for supporting for clinical validation for that technology. And we won out of 70 applicants. In 2015, got the money in 2016 from the Hemsley, partner up with Gluco. Initiated a randomized control study that I will show a little bit about the results of that study today. And, we decided that we have enough information to go to the FDA. It was my first time to talk about FDA, about, regulating a product. I didn't know how to do that at the time. And luckily for me, FDA didn't know how to regulate our product too. So we went into a journey together with the agency, learning how to regulate software algorithm that take data from continuous glucose sensor and recommend how to optimize insulin pump settings. Got that approval first time in 2018. 2019, we expand the approval to not just people with pump and CGM, but also to anyone with type 1 diabetes that is using an insulin pump, even if he's measuring his glucose with self-management glucometer. And as of today, the accomplishment that we have is, of course, we are very proud of the launch of the 780G. We are proud that the randomized control study that we did with our DreaMed Advisor technology and leading academic centers like Joslin, Yale, Barbara Davis, University of Florida. These results were published in September in Nature Medicine. We're expanded our indication for use of Advisor also for everybody with age above 65. So basically, we support anyone above the age of 6. We are right now deployed in 16 clinics in the U.S., 5 of which are the top notch in hospitals. We are participating in another study of M.Sc that supports virtual healthcare specialty clinic that I will share a little bit of that with you. And there are more plans that we have internally to share about automated decision support systems and what we can do for people with diabetes. So this is a very long, maybe, history of where we are 14 years ago when we are today. Now, just a little bit about what we're trying to do. So I think that all of you will agree with me that it's not that easy to manage glucose levels for people with diabetes. And I'm sure that you know this information about how much people with type 1 diabetes is reaching their glycemic control goals and how much of the type 2 diabetes on insulin getting these goals. Now, when we looked on these issues and we thought to ourselves, okay, what we can do in order to help these people. So for sure, especially for you, and I'm sure that you're feeling about that, having an automated insulin delivery, someone to make the decision for you or something that will make the decision for you is the best way to go. I think there is no question about that. But if you look on what is the essence of allowing something to make decisions for you, it's basically replicating the results that were published in the New England Journal of Medicine already in 1993. And what they showed there is that if you're doing frequent titration of insulin, you're managing to improve the glucose control of a patient. At that time, they did a weekly touch point between a healthcare provider and a patient, optimizing the insulin treatment plan. Automated insulin delivery or loopers are doing it into a frequency of minutes, but considering the fact that the majority of people that use insulin are not having an insulin pump, but rather doing insulin injection. So if we can create a mechanism that will increase the frequency of between an intelligent provider or a technology that review data and try to optimize the insulin pump settings or insulin treatment plan settings, or even recommend real-time dosing recommendations for people with diabetes on insulin, we have a much better chances to improve the glucose control. The problem, as you all know, and Joanne mentioned that very nicely, is that number one, we don't have enough experts providers that can do this job. And even those that we do have, we don't have time that they can do this process very frequently. Number two, with the introduction of continuous glucose sensors into the market, data become more complex. And you need to have a very certain expertise in order to review the data and understand what's behind that data. And I'm sure that if you look on that graph here, which was taken from a real person with diabetes, you will see a lot of mess. You know, he's high overnight, he's low in the night, he's high in the afternoon, he's low in the afternoon. So it's difficult to make something out of this mess. So the vision that we have at DreaMed is that if not everyone has the access to an expert endocrinologist, we will give this access anywhere, anytime using software. And the objective is to be there for people with diabetes through their day-to-day life to maintain the glucose control. And what we are trying to say, okay, we're going to develop something that will be specifically focused for people with diabetes that use insulin, either tracking their glucose with CGM, flash glucose monitoring technology, or self-management blood glucose meter. But it's very important to include in that solution also their health providers treating this population. So the DreaMed Advisor platform is an all-in-one solution to treat the people with diabetes, that by creating some sort of a shared environment between the providers and the users throughout their life events. The components of the system is, number one, a data system that can capture data from different kind of devices. We have a data partnership with Tidepool, with Dexcom, with Gluco. We have connected insulin pen that will come in pretty soon. And by gathering the data, like Joanne said, I believe it's power. And the way that we use this power is with a couple of things. Number one, we for sure visualize that data in a simple way, both to the provider and to the patient. Number two, we are running the data through insulin treatment plan optimization algorithms that recommend how to change in a very precise and a personal manner the insulin treatment plan of a patient. Then we can use the data also to have insulin real-time dosing algorithms. And at the end, it has to be presented to the user in a very easy manner using mobile apps or web application. I see that the chat room is boiling, and I don't know how much of it is question for me.
Aaron,
I will.
Well,
at the end
yeah,
of
what we'll do is we'll pick up a gap when it's, and then I'll try to group the like questions together. So I'm taking notes on the questions right now.
Cool. Thank you very much, Glenn. Okay, so I will move on. So just a little bit to share with you about the workflow. So basically, provider can prescribe the technology to a user. It has some sort of a start advisor program for that specific user. Then the user gets some sort of invitation, open up an account, connect his devices either through his Tidepool account or connecting directly his Dexcom Clarity account to advisor. We're going to support pretty soon some connected insulin pen and some BG meters that we'll be able to upload directly to our platform. We have our own education portal that you can get videos and manuals how to use it, and it's separated between the insulin injection therapy users and the insulin pump users. And right now, while we are not regulated to be used for people that use automated insulin delivery, because there is a certain regulatory gap that we need to overcome together with FDA, I think that for sure we do have the capabilities to cope with such a technology. You know, and the nuance is that in 2010, 9-10, we developed this first generation of this technology in order to optimize the way our automated insulin delivery algorithm works. So we believe that an algorithm that is rely on its math on the current pump settings of a patient you need to optimize the pump settings in order to optimize the performance of the automated insulin delivery algorithm, because at the end you have two decision cycles. One is, what is the sensitivity of the patient, how that sensitivity is being changed over time. And this is a decision cycle that is currently happening on the provider side. And then you have a decision cycle on the patient side saying, okay, these are my sensitive, this is my recipe for insulin therapy. Now I know what is my current glucose, what is my current meal plan, how am I going to calculate my dosage right now? And this is exactly what the automated insulin delivery algorithm, the one in Loop, the one in 780G, the 670G, the Control IQ, all of them are working the same. They're using a certain sensitivity and they're taking it as an input and make decisions. Going back to the flow, and then where the product is right now in the market for people with type 1 diabetes between the age of 6 and above 65. I'm sorry, this slide is not updated, with insulin pump. And we're going to submit by the end of this quarter what we call Advisor Pro 2.0. Here we're going to expand the indication for use for people with type 1 diabetes and type 2 diabetes that uses insulin with multiple daily injections or insulin pump, basically covering almost the entire spectrum of people that use insulin. The only one that we still need to solve are those who are using long-acting insulin just for basal only. So what advisor is providing? Here you can see screens, and I will try to zoom in so you'll be able to see it more clearly. So here is an example of the output of the algorithm for a patient with an insulin pump. So what the algorithm is saying, okay, doctor, pay attention. Here's the current insulin pump basal setting for that specific patient. This is what I'm trying to, what I recommend for you to change. All the changes are highlighted, and you can see how precise is the change between by the hour or by adding another basal profile between midnight and 8 a.m. by the amount. And the same way is going for people that are using sliding scale and recommendations for a long-acting insulin and how the bolus plan is look like from a sliding scale perspective, together with the type of the insulin, and also for people that are on carb counting that still use injection with carb counting. And here we have again the long-acting insulin plan and the recommended bolus plan. So this is one type of recommendation that we're delivering: new insulin therapy plan for multiple daily injection and for pump. The second thing provided in our report is a very precise comments that are taken from our automated algorithm, which highlights specific behaviorals that related to the way that the patient delivers the insulin, that if he will overcome those behaviorals, he has much better chances to improve the glucose control. Now, there are other softwares that provide these insights. What is different between what we are doing and what they are doing is a couple of things. Number one, we're trying to limit the amount of notice of comments here to no more than 3. And those 3 that we're highlighting are the ones that, based on our calculation, will have the majority of impact on the timing range for that specific patient. And we are also very precise on the time of the day that we identify the pattern, and that the belief that if it will change this specific behavior, it will have impact on the glucose control. So for example, I noticed that many of your highs may be avoided. Entering your blood glucose level into the bolus calculator may help. This type of message will only come up if we will see that the patient is basically missing units of insulin every time that he is delivering a bolus, and that if he will input the glucose level into the bolus calculator, he will be able to compensate with that missing insulin, and by that avoiding the highs. So it's very precise in the way that you analyze the data and provide the recommendations. Once the provider get the recommendations, he can always scroll down and see in one page all the different kind of data reports that he likes to see in all the other systems, going from ambulatory glucose profile, the AGP, to logbook, to daily reports, and everything is very interactive. You can hover with amounts on the reports and see all the data. After reviewing all the recommendations, all the provider needs to do at that time is to click approve and share, and then the patient gets a notification that a new recommendation is waiting for him from his provider, either through the mobile app or to the email with a link to his web application. And by that, we're basically facilitating a full electronic communication between the provider and the patient, facilitating what we call today a virtual visit between providers and patients. You know, anything that involves technology has some sort of hazards within it, because you need to make sure that when you're introducing technology to be used by people, that it actually works. Now, because I worked in a hospital for 7 years before creating the startup that is called today DreaMed. One of the things that I've been taught, and we're sitting in an engineering room with no windows yet, we didn't have any windows, working with the people that come to the clinic to get visits with the providers, working very closely with the providers, things that basically are a basis in our culture as a company is to say, listen, if it doesn't have any clinical work that it's proved, don't bring it out to the market. You're just going to waste the time of the people and the users and create anxiety that It's not the way that we are working. So by bringing this technology, we did several clinical studies. I will give you highlights about two who are very interesting. Number one is this study that we did in February 2017. And in that study, we took data sets of 15 patients and provided to 26 physicians, expert physicians around the world, and asked them to give their advice on how would they change the insulin pump settings for these specific patients. Then we took the same data set of patients and provided to the algorithm, and we did two levels of comparisons. One is between one physician to his colleague, and the other one is between physician and the algorithm. Now, question to you guys, pay attention. Does anyone want to guess what was the level of agreement about the direction of change of insulin, either to give more insulin, give less insulin, or no change of insulin for the same data set between one expert physician to his colleague? Open up mics. I want to hear you guys. What is the percentage of agreement between two physicians on the same data set?
I'm going to guess this, Glenn, 20%.
I'm going to guess.
Okay, Gay.
I'm going to guess 10%.
I'm going to go 50.
0%.
Yeah, I see Jessica raise their hand. Jessica, what do you say?
0%. No one agreed on anything.
0%. Wow, you appreciate your doctors very nicely.
I'm a realistic person.
Okay, so I will give you the answer. It was 42%.
Woo!
42% level of agreement. Now, here's a more difficult question. What was the level of full disagreement between one physician to his colleague? Meaning on the same data set, one physician say, give more insulin. The other one said, give less insulin. On the same data.
60%.
Yeah, I was going to say something like 50%.
No, it was 12.
There are so many possibilities.
So many.
Yeah, it was 12%. So 12% of the cases, two physicians on the same data set, one said give more insulin, the other one said give less insulin. Now, what we taught from that study is a couple of things. Number one, there is a huge diversity between what physicians are thinking about the same data set. Number two is that when we compare the data of the algorithm, what the recommendation of the algorithm said to what physicians said, we pretty much got to the same level of agreement, meaning that what we wanted to make, to create the notion that saying, come on, doctors, I know that you've been teaching, you will learn studying medicine for a lot of years, but if you will knock on the door and ask the algorithm what he thinks on the data set of your patient, the chances that you will get the same answer as if you're going to ask your colleague next door. So number one, the purpose of this study was to show, okay, there is a way to bring algorithms to work with doctors. But that study didn't tell us, okay, so who's right? Is the algorithm right or the physicians are right? Who will get to glucose control measures? How that impacts? So we told ourselves, okay, let's do a second study. And that was the study that was funded by Hemsley. We went to these centers. I think that there is no argument here in the audience that these, at least the one in the US, these are the top centers in the US, right? Joslin Diabetes Center, Yale University, Desmond Schatz, who was the former president of the American Diabetes Association, and Barbara Davis, they almost did all the studies with automated insulin delivery systems, right? So these are the top centers. And we said, okay, what will happen if we will take a group of patients and divide them into two? One will be treated by these doctors, and the other one will be treated by doctors that take basically the recommendation of our algorithm, just check they're safe, and pass it on to the patient. So it's basically expert doctors versus the algorithm. Now, I'm sure that some of you will like to say, okay, you wanted to design a study that the algorithm will beat the doctors, right? The algorithm will be better than the doctors. But that was not our intention, because remember, 60% of the people that has diabetes and use insulin are not have any chances to be seen by Dr. Lori LaFell from Joslin Diabetes Center. They just don't have a chance. They don't have a chance to see Dr. Jennifer Scher from Yale. So if we will create an algorithm that will perform the same way like these doctors, think about it. We'll basically be able to proliferate expert knowledge with the software. So the intention was to show during a 6-month intervention period that we're getting to the same glucose control as these doctors. And we managed to show that. And I think that even for the group of the patient that actually uses these frequent titration, every 3 weeks we change the recommendations for the pump settings. For these specific cohorts, the algorithm group even a little bit outperformed the experts doctors. A little bit reduced the hemoglobin A1C a little bit more than what the doctors did. So by the end of these studies, what we managed to get is that we have an algorithm in our hands that is capable of achieving similar thinking as experts and similar outcome as experts. Now it's our job as a company to say, okay, what will be the next step? So number one, the next step is to try to give it to any one of the providers around the world. We're now focusing on the US, but to endos, to primary cares, standardize the treatment, be able to generate more frequent titration between clinic visits. But maybe the second step for that will say, okay, like automated insulin delivery system, like Loop, let's give this technology directly to the hands of patients, that whenever they would like to optimize their settings, there will be some sort of a guardian angel that will go over the data all the time, retrospectively, analyze the data, and optimize the insulin settings of that specific patient. So that's where DreaMed is going, in the near future, after we will complete our approach into the multiple daily injections patients. I want to show you a short demo, just to give you a little bit about how the algorithm is thinking. And for that demo, I will use John, and I'm sure that he's younger from most of the audience right now, but I'm sure that you will remember that, one day he was his age, 11 years old. And I will use this example to show a little bit about how the algorithm thinking. And what I'm trying to say here in general, the theme here is that the algorithm make the same data analytics as experts will do. And we will see it in the example. So here's John. He's complaining to his doctor about occasional hypoglycemia. His A1C around 7.8. He has 6 years of diabetes. He's using the CGM for 1 year, measuring about 4 times a day, and he's delivering close to 5 bolus per day. And if you look on his timing range is pretty good for a patient that is not an automated insulin delivery, 63% timing range. But he has a lot of hypos. 3% below 54, it's a lot. 8% below 70 is also a lot. And we can see that he experiencing these hypos around midnight and sometimes in the afternoon. And about highs, so he has some highs, 18%, not that much, 8% above 250, and he specifically has these highs in the evenings and overnight. His basal is about 62% of his total daily dose, a little bit meaning that he's getting a little bit too much of a basal. Usually we prefer to have the basal between 40, 50% of the total dose. Getting up to 62% with a little bit of hypoglycemia, it's a little bit too much. Maybe he's compensating for the fact that he's not delivering enough boluses with the basal. So the question that a provider and the algorithm will ask themselves are, what is the causes of hypo events throughout the day? Are the hypos in the news in early evenings are coming from bolus or from basal? And instead of providing all of these reports to a healthcare provider and ask him to analyze it, if we're going to ask the algorithm, well, the algorithm will recommend is, number one, let's reduce the basal. And you can see that here from 9 a.m. until midnight, he's basically reducing the basal with almost 1.35 units per day. And this is exactly to avoid the lows throughout the day. And you can see here a clear example in the night that sometimes the glucose is dropping because of the high basal. And we know that changes in the basal take time to influence on the glucose. It doesn't mean that if you will change the basal right now, the influence on the glucose will be right now. It will always be delayed by about 2 to 2.5 hours into the future. Then, in order to avoid some of the additional doses, the lows in the late morning and the lunch, the algorithm recommends to change the carb ratio into a higher carb ratio, meaning to reduce the amount of insulin that he's delivering for meals. And you can see here also an example that when the patient delivers a bolus for a meal around 10 a.m. in the morning, he is getting into a roller coaster of highs and lows, highs and lows, highs and lows. What about the highs? So here, what the algorithm is recommending is not a change in dosing, but rather a change in behavioral. And the algorithm has a way to automatically detect episodes where the glucose is rapidly go up with no insulin behind it, and it's classifying this type of event as meals that the patient didn't deliver insulin for. And this is exactly the same algorithm that is within the 780G, that when the algorithm senses that there is a dynamic that relates to meals, it's where the algorithm a little bit changed the way that it's operating, the way that he's recommending insulin. So that's why he's providing a notice to the patient that many of the highs may be avoiding delivered bowls for every meal and snack may help you get into a better glucose outcome. So out of today, we have a little bit more of 1,000 users around the United States. Our technology is being used in the clinics that you see here, and many more didn't allow me to pull to their logo on the slides. Where at the beginning we were focused on pediatric endocrinology clinics. That's mainly because the fact that we are more focused on type 1 insulin pumps, no automated insulin delivery with CGM, NSF management, blood glucose meter. Now that we are going to expand to people with multiple daily injections in type 2, it will be much more adopted in adult endocrinology clinics, and I hope also with primary care in one way or the other. This is a very nice project that we have been involved in with Hemsley, the Jape Center in Cecilia Health. Our advisor platform has been chosen as the platform to establish a virtual specialty clinics for people with diabetes, where people can download data at home. This data, together with our decision support algorithm, is being reviewed by a CDE or a nurse practitioner, and recommendations are being sent directly to the patients. All is happening totally virtually without the need to have a face-to-face visit. This is a little bit of our data partnerships agreement. Right now, we have a partnership with Glucose, Typewell, Apple Health, Dexcom, Biocorp, which is a French connected insulin pen, and we hope that we will be coming to the US pretty soon. And with that, I would like to conclude and tell you, listen, we believe that it is the privilege or our duty as an industry to make sure that anyone with diabetes will have the optimal diabetes care. It doesn't have to be related to where that person is living, how much time does he have, if he's working full-time or 2 shifts and he doesn't have time to go to his doctor. He needs to have access to expert doctors or expert knowledge how to self-manage the disease by himself. And for that, we are committed to bring better technology that you will be able to live a fulfilled life with. If it's possible, think a little bit less about the diabetes, and if not, at least be able to manage it easier than what you have right now. So I appreciate the attention, and I will be happy to answer the plural of questions in the chat room with the help of Glenn that will help me navigate between all of these questions.
Oh man, I think this might. I should turn on my camera, but I have 3 pages of notes and I haven't even been able to group them yet. They're just all over the place. So
you want me to start from top to down? I can do it, no problem.
Well, let's go. I always like to go backwards because then it covers whatever was most recent. So there was a comment about virtual clinics and using, I guess, the software in a virtual clinic sort of situation. I'm assuming that that's also in a non. I assume that this will also work in a system sort of agnostic situation too, but maybe discuss that a little bit.
So this is a thing that we are trying to promote, and we try to do it in several ways. Number one, the project that Hemsley is promoting at this time, it's a clinical study. There is a national pair that is being recording for that specific study. And if you are interested, log into the JAPE Center, see if you are capable and are fit their inclusion criteria, and be able to join this study. So that's number one. I can tell you also about a service that we tried to build, and we actually shut it down a couple of weeks ago. We decided we'll build our own virtual clinic. We partner up with a couple of private endocrinologists around the U.S. And offer the service for $50 per patient per month to get as many as touch point with an endocrinologist as they want, together with our technology of decision support. It took us a lot of time to recruit patients for that service, and we decided to kill it because we just didn't see our financial ability to sustain that. That said, I think if you look on what happened during COVID, that before COVID, about 1% of the visits that clinics did with people with diabetes were virtual, and now almost 50% of the visits are virtual. There is a place to change from top bottom the way that the diabetes is being managed and the relationship between a patient and a provider. So we still try to push forward and try to think what will be the best business model behind it. I don't have a lot of news to tell you that, but it's definitely as one of the important things that we're working on our radar.
Is the JAB study? Oh, sorry.
Go ahead, Glenn. Yeah.
Is the JAB study the same study that was using the tide pool data with patients over like a 2 to 3 year period, or is there a new study?
No, it's a new study that was launched in August this year. So again, if you think that you would like to read more about that, just log into their website. I know there is a lot of information there. It's called the VDisc study. I will type it here in the chat room, so you will be able to read a little bit more about that.
You mentioned Dexcom and Medtronic, I guess, in the discussion as partners. Have you done any work with Abbott also? Libre 3?
Yeah, so Libre 3 is not in the market yet. They have Libre 2 right now. We are always trying to create relationship with Abbott. If anyone knows someone from Abbott, I'm joking. So we know Abbott. We're trying to work together with Abbott. At the moment, Abbott has a very strict data sharing requirements, and we're not able to work directly with Libre devices that download data through their app. We are able to pull Libre 2 data as long as they're able to download that data through Typal. So through Typal, we can get Libre information also.
How does sensor activity affect the system?
What do you mean sensor activity?
Like accuracy.
So the way that we manage the system is that, number one, only sensors that went through FDA approval can be used. So by that, at least we're ensuring a certain level of accuracy. Then the algorithm is basically reading data retrospectively over 21 days of data. And by that, we are eliminating all the artifacts that can happen from sensor accuracy. Now, I will tell you something that maybe only you can understand that because you have been here for a couple of years. Do you remember the soft sensors of Medtronic?
Oh gosh, they were horrible. Yeah, and
they were horrible, right?
Yeah, they was basically one step away from not having a sensor.
Yeah, it was about 20-30% accuracy level. So would you believe that we managed to do automated insulin delivery algorithm with a soft sensor?
Well, I think if you could do it on that, you could do it on anything.
That's right. So our first studies, the ones that were published in Diabetes Care, were done with soft sensor. And we even had study with Freestyle Navigator. Do you remember the Navigator?
I don't remember it. I think Joanne remembers it because
I loved it. It was fabulous.
It was amazing sensor. It just was cut off of the US, but it was a very good sensor. So I think that because we have a long history, we worked almost with any sensor in the market, and we know their pitfalls, and we know that Dexcom is a little bit reading higher than what is the actual glucose levels at the beginning. At least you remember the 7 sensor of Dexcom. It was a little bit reading high. So we know that, and we know that Medtronic sensor are always reading low, right? They are always reading low. And so we know the pitfalls of each and every one of these sensors, and our algorithm team knows it by heart. So that's why we know that applying a certain math on the data will basically fit on any one of the sensors, and we don't need to know the brand of the sensor in order to do that.
So many of us in looping, or not many of us, but a certain percentage of loopers are now starting to not use basal adjustments, and instead they're using ISF adjustments, so multiple ISFs in a day. Have you seen that data maybe in that way get analyzed in the system where multiple ISF periods are used to control certain types of events such as sleeping or early sleeping with carbohydrates still active and things like that, wake up times?
So our algorithm can cope with up to 48 different ISFs per day. Mainly one every half an hour. We usually prefer so that's the maximum, okay? We usually prefer no more than 8. I think that's a good number to have, around 8. And our average, patient and average treatment plan that we are issuing is roughly around 6-8 different kind of ISFs. And I think that what we learned from our studies is that providers don't want to change ISFs too much. And it's not because they don't know how to do it, it's because that they're trying to play with 3 factors: basals, carb ratio, and ISF. Mm-hmm. Sometimes they're also playing with the insulin activity time, right? For the human mind to analyze data and play with 4 parameters, that's too hard. So what they do is that they fix the insulin activity time, they fix the ISF, and they're playing with basal and carb ratio. And sometimes it works, but most of the time it doesn't work because, and one of the things that make them also very difficult is the fact that 80% of the boluses of people with insulin pump are basically what we called in our language combined boluses, right? It's a boluses that basically include also compensation for a meal, and compensation for correction. Now, how would a human mind be able to say, okay, this is how the correction play in the game, and this is how the carb ratio will play in the game? It's just tough. For an algorithm, it's much easier. So we know how to play the differences. Now, while we didn't actually fed into our algorithm any loop data, mainly because it was not approved by the FDA to do that, this is something that we'll reconvene once Type will complete their FDA journey. If that will be an FDA-regulated system, I think that will be the point where we as a commercial company will decide to take a hold for that too.
Well, that would be quite interesting, given that, I think that, Type will seems to be, marching pretty tough right now with Insulet. So that's hopefully going to happen fairly soon. Let's talk a second about control goal. When you were talking about control goal, were you using the standard 70%, 70 to 180 in your in that one early chart you had, the 20% compliance chart?
Yeah, the 20% compliance chart is even not talking about timing range. You are very much advanced people talking about timing range, but these charts were creating about A1C. People still use A1C. And I think that there is a big debate about what should be used. Should we use A1C or should we use timing range?
Well, effectively, 70 to 180 gives you about 7% time and range usually. So, I mean, I think that's the sort of the 7% is kind of 70 to 180 at 70%.
Well, I agree with you, but I would like to give you another perspective into that. I think that timing range is good for motivating a person with diabetes to improve because it's a metric that he can feel.
Right.
It's a metric that he can feel it, right? He can know what it means to him. It has simple understanding behind him. But when you're looking on a period of the patient, not just a day-to-day, but a period, you should also consider the A1C, because the A1C gives you some sort of an average perspective on what's going on, filtering out some of the days where there was fluctuation in the glucose that the patient, even if he tried very hard, he couldn't avoid that. And so that's why I think it's important to have both metrics and try to use both of them for different kind of purposes.
Yeah. So what type of achievement are you getting versus the 20% that was in the chart once people are using the system or perhaps the Medtronic, one of the Medtronic applied pieces that's using your parts?
So for automated insulin delivery, if you look on the data that was published about the 780G, we're getting to about 80% timing range, which is pretty good for a broad population. Not all of them are motivated to be able to do that. So we're getting into the area of 80%. For people that are using our advisor technology, we're managing, again, depends on where they are. We are managing to reduce their A1C between 0.4 to 0.7 in the A1C, and keeping them constantly on around 50 to 60% timing range, which is for a patient, on an average patient that uses an insulin pump, usually the timing range is relying between the 40s, 40-something to 50-something. The average when you look on a population. For us, we're getting them to around 54, 60.
Have you done any work to integrate like motion into the algorithm, like activity, exercise, or mouth motion?
That's an excellent question, and we have debated that pretty longly internally. Here's my take on that. I think that if there is information that we can gather by just looking on the glucose and the insulin, there is no need to add more noise into the system. Now, physical activity is expressed in the glucose and insulin because during the physical activity or a little bit later after the physical activity, glucose behave differently to insulin, okay? Either there is an absorption and then glucose is much more sensitive to insulin, or there is an adrenaline, then you see the effect of the insulin on the glucose on the later stage. So you see that glucose and insulin information is being captured by the physical activity is being captured by glucose and insulin. Or one of our automated insulin delivery studies, we even took people to treadmill and make them do running in a very extensive study with physical activity and just saw that the output cope with that even without the information that there was physical activity around it. With DreaMed Advisor that do retrospective analysis of the data, as long as there is a certain pattern of physical activity for a certain time of the day, we're able to capture that by just looking on the glucose and the insulin. So the short answer is no.
Yeah, okay. Have you looked at female monthly cycles also in for data integration, since females generally have frequently have a hard time with monthly cycles?
Yeah, we didn't look into that, as getting that as an input from female participants, but I can tell you that we have a lot of females that use the technology. So again, maybe it is something that is being implied in the way that glucose and insulin are being related. Maybe the fact that is, on some females, it is within 1 week that this difference is happening compared to the others. So this specific week is being blended as an average between the overall 21 days of analysis. I think from an automated insulin delivery perspective, the fact that we're able to provide recommendations and active insulin recommendations on every 5 minutes, I don't see why the physiological thing that the female is within her period will have any impact on that. Because if the algorithm sense that there is need to have more insulin, the algorithm will deliver more insulin.
Yeah. Okay. For those of us that some of us do use type pool that are loopers, is there a way that is there perhaps at some point in time going to be some type pool integration, given that you're working with Helmsley and type pool and that sort of thing, so that some of the features can show in type pool?
We already work with type pool to pull data. So for example, if you are within your provider and your provider has type pool, the provider can connect his type pool account to our account, and then all the information, as long as you will give your permission, will be able to be analyzed by our algorithm. The recommendation of the algorithm will not be embedded within type pool, mainly because type pool doesn't have the resources to do that and maintain that. And every change that we are introducing to the market, they will need to change the UI on their end. And that was the decision that we came along together to make sure that they have their system, we have our system. We're working collaboratively to share data between the systems and be able that if type pools, people would like to share the data with DreaMed Advisor, they will be able to do that from a technology point of view.
Do you think there's going to end up being a new sort of job title in the workforce that goes outside of the traditional nurses, CDs, and doctors to be like, diabetes analysts?
I think that, I don't know if it will be a diabetes analyst, but I think that the future will look on more centralized places. For example, in a certain county, I see a way that all the diabetes people on that specific county will be managed by a remote watchtower. That in that watchtower, there will be some sort of a, nurse practitioner that will be able to answer your needs whenever you would like to get that 24/7, hopefully. And then for only And that watchtower will have algorithm that will tell you know what, you need to see your doctor right now because I'm trying to manage you and trying to give you recommendations automatically, and it just doesn't happen. You need to see your doctor. Maybe there will be some people that will see their doctor more frequently than once every quarter. Maybe some will see their doctor only once a year because they don't need to do that. I believe that there will be much more of in the way diabetes is being managed. Yes.
Yeah, I think it's an interesting idea, especially, Loop really has, there is no AI in Loop. So the AI right now is us because Loop basically is an algorithm, but it doesn't adjust data based on changes. So, we're the ones that have to look at our data and go, oh, we need to tweak this. We need to change our carb ratio. We need to adjust our ISF, or we need to adjust our basal or basals. So we're kind of the AI. Have you by chance looked at, some loopers use auto tune. I don't think it works super great, but have you looked at auto tune in the looping community before?
So yeah, I know of auto tune, and I looked into that. I think it was a long time ago. I don't know how much it was advanced in recent years. At that time, when I looked in that, it was only able to support one ISF per day, one carb ratio per day. I'm sure it was advanced since then. And I think that if it's a tool that helps people, use it. I don't see any reason. I think that a lot of the persons with diabetes know more about themselves than anybody else. And if there is anything that you believe can do you a good thing, go for it. You don't need to wait for that. I think it's our responsibility as an industry to make sure that we are generating technologies that are being validated for a population, making sure it's safe, making sure that we're going through all the routes to regulate that, because at the end, our job is to create something that will work for a lot of people and a lot of typecast of people, and think about all the nuances can happen there. And that's why sometimes our job takes more time than loopers and DIY and everything.
Yeah.
And that's why you are able to do things maybe a little bit faster, but you always need to be cautious about what you do. And frankly, there is no one that can tell you what to do. Even before the DIY, a person can decide that he would like to deliver 20 units of insulin bolus for a meal, and nobody can tell him no for that. So at the end, it's your responsibility to take care of yourselves, and I think that there is no one that can tell you what to do.
Well, Joanne, please step in if you think you saw anything, or even Joanne, Mark, Priscilla, Carol.
I'm really curious. Is there one algorithm, or are there a variety of algorithms? And does the patient have any choice to say, I want to be lumped in with the average people who aren't that concerned about being that under control, versus people like loopers who are much more actively involved in doing that? Could we choose algorithm A or B, and with our do we have input?
Okay, so with the DreaMed Advisor right now, we have one algorithm, and it's one algorithm that basically has the same set of goals. So it's trying to direct the glucose control to a certain range, and it basically reads the action that you are doing in response differently based on your action. So if he will see that you are delivering a lot of boluses, he will have more data points to analyze, and that's why his recommendation will be much more accurate. He will analyze your glucose sensitivity to insulin, provide a very precise way of recommending the changes. That's the way where the algorithm is differ between one person to the other. It's the same logic of thinking, but it responds differently to data sets per person. I think that it is our intention in next versions that we will have, maybe to allow doctors, not patients at the moment, doctors to adjust the aggressiveness of the algorithm, saying, okay, that patient likes to be a little bit lower than the others, So please be more aggressive there. Regulatory point of view obligates us to put these decisions within the hands of doctors. But as you all know, aggressiveness of therapy, it's always a dialogue between the person with diabetes and his provider. So it's not a decision that the provider, takes by himself. So I think that the future versions will have that mechanism embedded inside, and that's what will allow you, with a discussion with your provider or app provider, to set the aggressiveness of the algorithm.
Yeah, I could totally see like a sort of like a pregnancy algorithm where, a doctor would say, I want this person to be 70 to 130, 90% in range, no more than 2% low, for like a highly controlled pregnancy, for instance.
For example, or a child that, age of 6 or 4, that he say, during school time, I would like him to be a little bit high because it's just a waste of time to get in a low within school.
Yeah. And you have to deal with recess and all kinds of recess, eating time, eating amount, and all kinds of variables like that.
Yeah.
Does your algorithm have anything to do with, you set target ranges?
So we're not recommending right now a target range, but what we do is that we read the target range that is being set into the Boltz calculator. So if you are targeting your bolsters, to a lower target, we use that information and try to optimize the pump settings towards the target that you put to yourself in the Boltz calculator. So we are considering the target that is being set within the Boltz calculator.
I think we as loopers who do so much interaction have a little difficulty wrapping our heads around AI making those decisions. Do you consider yourself somewhat similar to what Beta Bionics is doing in their iLet, which makes those adjustments as well?
I think that, Beta Bionics is basically another way of doing automated insulin delivery, but they're deciding to include also glucagon. And I think that their first version will even not going to have a glucagon at the end. So, they started with, a bihormonal system, and they rely into the fact that maybe there is no need to have a glucagon because you can achieve a lot of the achievement with insulin only. So that's Beta Bionics is another company that do automated insulin delivery. They have an excellent result. I think that they have promised there very much. In terms of what we're trying to do is that, there is the automated insulin delivery algorithm that we license to Medtronic, and there is a retrospective analysis of data. It's a different way of thinking. And I think that in the action of how can we rely on an algorithm to make a decision for us, is it safe enough to do that? You have to understand that at the end, this is exactly the questions that the agency is asking us as an industry. How can you make sure that your algorithm is safe? So for example, in our advice of algorithm, we cannot change the insulin pump setting more than 30%. That's it. Every decision is no more than 30%. And we need to show clinical evidence behind it, that it works. So I think that that's the way that we are making sure that the algorithm is safe. And this is the same methodologies that Medtronic followed to the approval of 670G and what Tandem has done with the Control-IQ and the Basal-IQ. So it's pretty much the same standard of care.
Did you have any? Did you have any part of? Oh, did I? Did you have any part of the?
No, Joanne was me.
Okay. Did you have any part of the algorithm in the 680G or the I forget the interim pump that sort of just come out in the U.S. Or is it?
Yeah, the 680. So we are part of the 80 algorithm. So Medtronic has a way to mark their products. They have the I think that they launched now the 770G, and they maybe intend to launch the I don't know if they intend to launch the 680G in the US, but just for you to know that the first number is basically indicating what type of pump technology is it within. So you have the 6 series pump is their pump that they have right now, the 670. 7 series pump is their pump with the Bluetooth communication to a mobile application. So that's the difference between the 6 and the 7. And the 80 or 70 is a type of the algorithm. So the 70, the 670 or 770 has the 70 algorithm, meaning just a change in the basal rate. And the algorithm that is marked by 80 also has automatic correction boluses. So we are part of the 80 algorithm. Some of our technology is embedded within the 80 algorithm. And I don't know what is the plans of Medtronic from that, but they launch outside of the US what they call the 780G, meaning the 7 series pump with Bluetooth connectivity and the 80 algorithm.
Yeah. Yes, I think it's announced for launch, but not out yet. Correct.
In the US, no.
Yeah.
In the US, not. But outside of the US, it's already been launched.
Have you done any work with Tandem?
Not at the moment, no. Always trying to create more work, but not in the moment.
How about with Roche with their solo patch pump, which isn't in the US for some reason, but there's only one pod or patch pump available to us in the US. And I don't understand that because that seems to be a very favored approach. And have you looked at them at all or looked at other pumps that aren't in the market yet?
So I don't know if you know, but the patch pump that Roche had is basically an Israeli company.
Yep.
They acquire.
Yep.
Yeah, Medingo, correct. Yep. As far as I know, again, we tried to create and contact Roche. We didn't manage to do that. As far as I know, Roche didn't launch their patch pump anywhere in the world,
right.
Not just in the US. And if I'm looking outside of the US to have, who is the big manufacturer of patch pump? I think it's only Insulet.
Yeah. There's something.
Again, from what I know.
Yeah, there's some place in Europe, someone sent me a link, I think maybe in Denmark, but I'm not quite sure. It just baffles me because that seems to be a highly desirable pump particularly for kids. They don't have to have tubing. And why it isn't.
Yeah, there used to be a UK company called Cellnovo, but I think they just didn't manage to fly.
Yeah.
I agree that the concept of a patch pump is ideal with no tubing. I think there is a lot of challenge in creating manufacturing line that has a very low, production cost. I was fortunate to be invited by the executive team, one of the executive team of Insulet, to visit their manufacturing place in Boston area. Guys, it's amazing. It is an amazing place what they have built there. Kudos for Insulet. Their CEO, she did an excellent work with all their team there. And I think that Insulet really managed to excel the manufacturing process, and that's why they're able to create a lot of parts with a certain accuracy. And I was amazed by this visit. It was an amazing place.
Tobias in Denmark mentioned I don't know how to pronounce it, Kaleido pump, which is Dutch, and it works with Diabeloop. Are you familiar?
Yeah, Diabeloop. We know about Diabeloop. We met them a couple of conferences, but no more, than that. No, don't have any connections there.
Okay, I have one more question and one more request. The question is, can your algorithm, or how does one put into the algorithm when you've had a pod or a pump failure or cannula problem or high stress or illness or a cortisone injection or infusion problems with absorption? How does that take that into account, or how do you input that?
So number one, the guidelines to providers is not to use the algorithm if there was anything unusual that happened in the past 21 days. So if you was ill or hospitalized or something happened, these type of periods are just contraindicated for the use with the algorithm. If there's a problem with the pod or problem with the injection area, we actually are able to detect that automatically. We just see the glucose is not responding to insulin. And by that, we are just eliminating that data of the analysis automatically. You know, we need to have at least 12 days of what we call valid data in order to produce a recommendation. And if we're not able to achieve that, we just don't make any recommendation at all.
So if the algorithm sees that there is a problem, would it flag someone to immediately get in touch with the patient?
No, it's not a real-time algorithm. So we are analyzing data retrospectively. So it's not a real-time algorithm at the moment.
I could say we would love to have that, particularly when our pods fail in the middle of the night and they're not screamers, but they just stop working. And you wake up at 400. So put that on your wish list. We really like to know about that. The DIY community is large, larger than anyone ever thought it would be. And particularly in SoCal Loopers, it's a very interactive and very supportive community. We would love to test things for you and with you. And if there's any way you could see to tap into us, I'm speaking for everyone. Not if you're in agreement with this, but the admins have all been discussing how are all these AIDs going to work with the current medical offices, and how are people going to get what they need? And it's a scary proposition because most healthcare professionals are not ready for this. So we see the need for what you're doing. And I know my admins are ready to jump in and help. Anything that you can think that would be useful to ask us or interact with us, we'd be very interested and willing to do.
So I think that there are a couple of things that we need to remember. In order for us to create something for people on automated insulin delivery, any type of insulin delivery, automated insulin delivery, at the end, we need data. What is difficult for us to collect is data of people that uses these DIY algorithms or control IQ algorithms, 6-7-EG. So that's one problem. One problem is that we don't have data. And because we don't have data, we just don't have the ability to train the algorithm to work with this type of data. Secondly, we cannot legally put to the market a product that is and say in the indication for use that it is supporting non-regulated products. I think that is what we have a little bit problems from a regulatory point of view. And again, I think that, knowing Howard Luke, he has fire in his eyes. He will make it. He will make it. I trust him that he will make it. If he will say that he will regulate Loop, I believe him. And I think that the moment that he will do that, that will be the place for us as a company to say, okay, we can support these loopers and this type of technology, but we still will need to have data. So if you would like, there are a couple of, 2 years ago, we were able to get from Tidepool data because they have their data donation project.
Yep.
Right.
Yeah. So we were able to get through this data donation project because we are partners of Tidepool. We were able to get data that support some of our development. And I think that there's people here that feel, okay, I like what this company is doing. I'm okay to donate my data and would like to contact with me later on. And we can try to find ways how we can do it in a safe manner, keeping your privacy, your personal health information, making sure that the data is being kept in a secure place. I will need to talk to my chief security officer to make sure how we're going to do that. But if there are people that are interested in that, contact me after this call. You have my contact information, or either Joanne will be able to give it to you guys. And we will find a way how we will be able to use the data in order to, again, generate technology that can help you manage your diabetes better.
That would be great. There is a built-in way of sharing our data. It's just, we issue reports, and we did it all through the JABE study. So anyone on DIY Loop knows how to do that. And maybe you and I talk and see if there is something that becomes a formula for what works for you and helps us in some way get you closer to what we do. That would be wonderful.
Hey, Joanne, did you want to possibly ask Matthew's question, or or I can read it out too?
Yeah, go ahead.
Maybe call that the last question. Are you able to speak concretely about the advisory and/or automated delivery algorithms? And I think, but I think what Matthew might be saying is he's confused between the two. You have two channels of business. One is the advisory service, and then the other is the automated delivery algorithms. And I think that they maybe got crossed over a little bit in the discussion. But
I can clarify.
Okay.
I mean, I wouldn't say that I'm confused about the difference between the two. I'd just like to know kind of fundamentally like how they actually work. Like, are you able to either speak to that directly, or like, are they published in any way that we can kind of just like wrap our heads around concretely what kinds of models you guys are using?
Okay, so I think that there is some public information about our automated insulin delivery algorithm, which is available in a manuscript that was published in 2010 in Diabetes Care. If you Google my name, you will be able to see that. So we shared some of the information there. We have not shared information about how the advisor algorithm is working. I think that you will understand why. And I can say that as opposed to other algorithms that use mathematical models behind it and differential equations, the way that we're working is more about statistical heuristics and decision trees and something like that, and the fuzzy logic model behind our automated insulin delivery. So there's not a lot of math there, to share very specific formulas or something like that. And that's why we decided to share what we decided to share and to keep as a secret what we kept as a secret.
Okay, and Cassidy just put up the link to your diabetes care article. So Matthew, if you want to grab that, that'll help you. I just want to thank you so much. I know we worked on getting dates, and I know you're close to bedtime, or I assume you are. Thank you. Thank you for your time. Thank you for the work you're doing. It takes two villages to deal with diabetes and to manage it, and it's almost an impossibility, as you said, in one person's brain. It's not doable. There are so many variables. So thank you for what you're doing. I will forward you any more questions that come up, and just wonderful. Thank you.
Sure. You're welcome.
All right.
Thank you very much.
Thank you so much. Bye-bye.
Bye-bye.